All right, today we got linear functions, slope, and a few applications. This should be a lot of review for you. Hopefully, nice, easy day. Let's see how it goes. First of all, linear functions. Linear functions are functions whose graphs are just lines. If you look at the top picture up here, we have two pictures of linear, this one and this one, because they're lines. Two pictures of nonlinear because they're not lines. All right. Definition: linear function is linear if it can be written like that. F of x is mx plus b, where m and b are constants, which just means there are numbers that don't change. That if you recognize that, that does look like slope-intercept form. If the slope is 0, the function is a constant, which means it does this right here. There it is at the bottom. It's a horizontal line. If the y-intercept is 0 and the slope is 1, it's called the identity function, f of x equals x or y equals x. And think about that graph. It's right here. If y equals x, that means it must go through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4 because y equals x. And the first graph, I'm kind of going backwards here, but the first graph is just a plain old linear function where m and b are, not 1 and not 0. So just a kind of a diagonal line, which is usually the case. Horizontal and vertical. Horizontal line is if you just have a y. Y equals -3, which means the slope is 0. It's got to cross the y-axis at -3, and that line is going to look just like this. So it's kind of backwards of what you think, because a lot of people remember that's the x-axis, that's the y-axis. But if all you have is a y in your equation, like y equals -3, it is a horizontal line. And that's a function because it does pass the vertical line test. The second one, vertical, is if you just have an x. X equals 4, which means it must cross the x-axis at 4. And it's going to be a vertical line right through 4, just like that. And it's not a function because it would fail the vertical line test. So horizontal, vertical, horizontal y equals, vertical x equals. Slope is m. Slope doesn't make much sense. 3 ways you can think of slope today, really 4 ways. First way is rise over run. I'm sure you're familiar with that. Also the change in y over the change in x, and also y2 minus y1 over x2 minus x1. You should have seen all of those in Algebra 2, all of those in Algebra 1. No big deal. Slope is all, I can't wait to say this. It's in this video later, but slope is also a rate of change. It's called the rate of change, same thing as slope. All right, graph this one, -2/3 x plus 1. I'm getting ahead of myself here, but they kind of want you to plot x and y coordinates here, but instead of doing that, I say let's just do the slope. Like that's the slope, that's the y-intercept. You know slope-intercept form already. The y-intercept is 1. Slope is -2/3, which means you got to rise -2, run 3. So I'm going to go down 2, right 3 on that one, and connect the dots, and there it is. Everything you graph will be linear today. An application, it says construction laws regarding access ramps for the disabled state that every vertical rise of 1 foot requires a horizontal run of at least 12 feet. And that's a good thing because that means all your handicap ramps are very long, which makes it easy for them to get up and down. What is the grade or slope of such a ramp? Well, slope, remember, is rise over run. This one's going to rise 1 and run 12, and that's it. That's the grade or the slope of that ramp. It's just rise over run. Very quick, very easy. Try this one. This is where slope is rate of change. Just what I was telling you earlier. Let's look at this one. The percent of American adolescents ages 12 to 19 who are obese increased from about 6.5% in 1985 to 18% in 2008. Find the average rate of change from 1985 to 2008, and who's the percent of adolescents who are obese. Sorry about that. Got a little stumble there. What I'm going to do first is write them as ordered pairs and say, okay, in 1985, it was 6.5%, and in 2008, it was 18%. It's not a good trend there. I guess I should have left the percent signs in there. So what I'm going to do is I'm going to find the slope or rate of change. Rate of change is slope. Subtract your y's, which is 18. I'll put the percent signs back in. 18% minus 6.5% over the years. 2008 minus 1985. On the top, it would give me 11.5%. On the bottom, it would give me 23 years, which is rounds to this 0.5%, which is basically saying that it's increasing on average of 0.5% per year. Hopefully that trend has stopped. Slope-intercept form, talked about that a second ago, got ahead of myself. Is f of x equals mx plus b, where m is your slope, slope's in front of your x, b is the y-intercept. M and b, slope, y-intercept doesn't make much sense. I personally think that M and B are great initials, some of the best there are, but that makes much sense for slope and y-intercept, but you need to know them. All right, next, the last slide, find the slope and y-intercept. So the first one, the slope is just negative. I'm gonna put 1/4. I like fractions better for rise over run. Y-intercept is negative 3.8. That's all they're asking you for there. And the second one, you got to put it in slope-intercept form before you can tell the answer. So what I'm going to do to make things a little quicker is I'm going to move the 6y over there. You could also move the 3x and the 7, get the same answer eventually. Now I'm going to divide everything by 6 because I need the y to be isolated. So I would get 3/6x minus 7/6. That 3/6 will reduce to 1/2 x minus 7/6. So what that tells me is my slope is 1/2. My y-intercept is negative 7/6. All there is to that. All right, the last thing, graph y equals negative 2/5 x plus 7. Lucky for us, this is already in slope-intercept form. So my y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to put a point at 7. Now, I'm going to use the slope. You need 2 points to draw a line. I'm going to use the slope to get my second point. And you don't start their second point from the origin, start it from your y-intercept. So my slope here is negative 2/5. So I'm going to start at the 7 and go down to right 5 to right there and just connect them. And there's your graph, there's your line. So everything you graph tomorrow in class will be linear, will be a line, so no big deal there. Hopefully it wasn't bad. Should have been a lot of review in this video, and we'll work on it tomorrow like we always do, and I'll see you then.